Okay, so here's another question, question number 2. Let's read it. A boat traveled downstream and back, and that's 210 miles in each direction. It took the boat 10 hours to travel downstream. That means with the current. And it took the boat 70 hours to return upstream against the current. What was the speed of the boat in still water? Meaning, what would the readout be on the speedometer of the boat? And what was the speed of the current? So, we're looking for two things: boat speed, speed of the current. But before we do our defining of our variables, I want to make sure that all of us, especially our ESL students, understand exactly what's happening. So, here's a boat, and here's the water. So let's say that the stream or the river is flowing this direction. So when the boat is going this direction, it's obviously, got its engine on and it's going this way, but the water is also pushing it. So their speeds would be added together. If the boat is moving at 10 miles an hour and the stream is moving this way at 10 miles an hour, well, it would just be the same situation as you walking. Have you ever been to an airport where those moving walkways are, and you get on it and you're walking? So you're going, it feels like you're running, as far as if you look off to the right, you're moving fast enough against the shops and the tile floor that it feels like you're running, but you're actually just on a moving walkway. So that would be a similar scenario here. The current is moving this way and the boat is moving this way, so you would add their respective speeds together to get how far the boat is moving. Now the opposite is true on the return journey upstream. Now the boat is traveling this way, but the stream is still traveling this way, thus working against the boat. So here you would need to subtract the stream's speed from the boat's speed. Now we're assuming for this example that the boat is traveling the same speed in each direction. That's why it takes only 10 hours to go downstream, but 70 hours to go upstream. So this is the scenario that we are working with, and this is the scenario that we need to represent. So now let's go ahead and define our variable. Let x represent, let y represent. All right, so we know that x is going, let's look for our question. What was the speed of the boat and what was the speed of the current? So it doesn't get much more obvious than that. Let x represent, we'll let it represent, I don't know, it doesn't matter which one you choose, the boat speed. And let y represent current speed. Now some of you, I'm hoping, noticed this is not appropriate. I have not appropriately defined my variables. Right now I would expect someone in the class say, that's not good enough, we need to be more specific, and that is very true. You would need to put in miles per hour. We need to be specific. Speed is not specific enough. We need to be specific about what our variables represent. So there, that's much better now. Let x represent boat speed in miles per hour. Let y represent current speed in miles per hour. So we've got the speed of the current, and for ESL students who don't know what this word means, it means kind of the flow of the water. So you know how water in a river flows a certain direction? That's what we call a current. So we've got speed of the boat in miles per hour, speed of the current in miles per hour. Okay, so now we have to come up with some equations. So let's think about what we're given. In this scenario, we know that the boat speed plus the current speed will cover 210 miles in 10 hours. So, traveling for 10 hours at a speed of x plus y, the boat speed plus the current speed. So this is a miles per hour times the hour will give us the total distance traveled. So let's make sure that this makes sense. 210 miles is equal to this miles per hour times the hour, total hours traveled. So this does make sense. If we travel at this speed for 10 hours, we will cover this much distance. So that's our first one. Now we have to represent, so this one's check, that one's all good. Now we have to represent the other scenario, this one over here. So let's figure this one out. It's going to be a very similar equation. We know that the total distance covered will be 210 miles. But what is our speed and how long do we travel at it? Well, we know that we travel upstream for 70 long hours. It takes a much longer time to travel upstream. We also know intuitively that if the boat speed is less than the current speed, this boat would not actually be able to go. So if this is 10 miles per hour and the boat is traveling at 9 miles per hour that way, it's actually going to get in and be carried further downstream. So we can assume that our boat speed is greater than our current speed. But how would we represent it? We would now have to say this is equal to our boat speed minus the current speed. So the speed that we are traveling here is the sum of these two speeds. The speed that we are traveling this way is the speed of this minus this. So here are our two equations. So let's rearrange these equations into a form that has two variables on the left side of the equation and a constant term on the right. Two variables on the left and a constant. So all we have to do is distribute. So use your distributive property to get these numbers inside. We'll have 10x, 10 times x is 10x, plus 10y is equal to 210. And over here we'll have 70x minus 70y equals 210. So now I'm going to use elimination. This is the equation I'm working with, and this is the equation I'm working with. I want to use elimination to try and get rid of one of these terms. So I'm just going to multiply this whole equation here by 7. So here we go. Let's go 7 into here. That's 70x plus 70y equals 210. So now that I have this equation with a 70x term and this equation with a 70x term. Oh, here, I've forgotten to do this. There's my mistake. Sorry guys, my brain is foggy. I didn't distribute the 70 over here as well. Or sorry, 7. So 7 times 210 is going to be, just give me a second here, 1470. So there we go, that was my mistake. I knew something didn't look right. So here's my two equations. I've increased the whole value of this equation, including that term, by 7. 7 times here, and times here. So now I have this equation and this equation. So let's put them on top of one another. I'll use this one first. 70x plus 70y is equal to 1470. 70x minus 70y is equal to 210. We're going to subtract these equations from each other, hopefully forming a zero pair. Is this still in the shot? Still good. Okay, positive 70 minus a positive 70. These form a zero pair and cancel out. Positive 70 minus negative 70. Again, if your grade 8 math serves you well, you'll recognize that that is 140y, same as adding 70 to 70. Positive 1470 minus a positive 210. That leaves you with 1260. Try to work ahead of me if you guys can, by the way. Standard practice. 140, divide each side by 140 so we can isolate y. And when you divide that side by 140, you get y equals 9. So what does that mean? It means that the speed of the current is 9 miles per hour. So now let's go ahead and plug in y for one of our equations. I'm just going to use this one, 10 x plus y equals 210. 10, and then in brackets, x plus 9 equals 210. 10x plus 90 equals 210. 10x, now let's subtract 90 from each side. Subtract 90 here. 120. Divide each side by 10. And x equals 12. Okay, so what have we just solved? We have just solved that x, oh, hopefully I didn't go out of frame there. Looks like we're all good. We just solved that x, which was the speed of the boat, is 12 miles per hour. And y, the speed of the current, is 9 miles per hour. And this would be your boxed final answer on a test.